Hi all. Today we are going to see about DFS, Depth First Search. It is an uninformed search algorithm since it has no information about the path cost from the current state to the goal state. It is called the depth first search because it starts from the root node and follows each path to its greatest depth node before moving to the next path. DFS uses a stack data structure for its implementation. DFS uses the concept of backtracking. What is backtracking? Backtracking means traversing to the previous node from the dead end node. What is dead end node? The node from which no further searching or traversing is possible. Then the node is called dead end node. DFS algorithm starts searching from the root node of the tree and explores all possible nodes along each branch before performing the backtracking operation. Next, we can see the DFS algorithm. DFS can be applied for both tree and graph data structures. Here, the function named as tree search is the DFS algorithm for the tree, and the function named graph search is the DFS algorithm for the graph. The function will return a solution if the solution is available, or it will return failure or error if the solution is not available. To perform DFS, two lists are maintained named as frontier list and explore list. Frontier list is created by using stack data structure. The frontier list is initialized by initial state of the problem. Next is the explore list. The explore list is the output list or the resultant list. The final DFS traversal ordering can be obtained from the explore list. Initially, the explore list is set as empty. If the frontier list is empty, then the function will return an error or failure. The leaf node is removed from the frontier list and inserted into the explore list. Find the adjacent nodes or child nodes of the root node or leaf node and insert those nodes into the frontier list. Perform goal test at each node to check whether the goal is reached or not. If the goal state is reached, then return the solution from the explore list. Else, repeat these steps till the goal state is reached. Next, we can see one example for DFS algorithm. This is the given tree in which we are going to perform DFS. Two lists have to be maintained. They are frontier list and explore list. Frontier list is implemented using stack data structure. During traversal, the unexpanded or unexplored nodes will be inserted into the frontier list. Explored list is the output list and it will contain all the expanded nodes. Next, we can see the steps one by one. First, insert the root node or the initial node, here it is A, into the frontier list. Remove A from the frontier list and place it in the explored list. Find the adjacent nodes of A and insert into the frontier list, that is B and C. Next, remove C from the frontier list and place it in the explored list, since C is at the top of the stack or the frontier list. Now, the explored list contains A and C. Next, find the adjacent nodes of C and insert into the frontier list, that is F and G. Now, remove G from the frontier list since it is at the top of the stack and place it in the explored list. Next, find the adjacent nodes of G. Here we are having adjacent node of G as J. Insert J into the frontier list. Next, remove J from the frontier list since it is at the top and place it in the explored list. Next, J doesn't have any adjacent nodes. We can remove F from the frontier list since it is at the top of the stack. Next, F also doesn't contain any adjacent nodes. We can remove B from the frontier list since it is the only element as well as which is located at top of the stack and place it in the explored list. Now find the adjacent nodes of B. They are D and E and insert D and E to the frontier list. Now Remove E from the frontier list and place it in the explored list. Next, find the adjacents of E, that is H and I, and insert H and I to the frontier list. Now, remove I from the frontier list and place it in the explored list. Since I doesn't have any adjacent nodes, we can remove H from the frontier list and place H in the explored list. Then we can remove D from the frontier list since this is the only available element and place D in the explored list. At this point, the frontier list is empty and we can stop our DFS. The explored list will gives the final DFS order for the given tree. That is A, C, G, J, F, B, E, I, H and D. So this is the DFS order for the given tree. Thank you.